Thank you for joining us for another episode of Buildings of Tomorrow. In this episode, we'll be talking about heat pumps, which is not just exciting because of the conversation that's coming up, but also because it's one of the topics that we're featuring at the Mostra Convego Expo Comfort from the 12th to the 15th of March this year in 2024. So if you ever find yourself in Milan, make sure you come and find us at the Siemens booth to talk about heat pumps, controllers, magnetic expansion valves, and other exciting things around equipment automation. Thank you. I'm really lucky to be joined by Alexander Jekimow, who is the Global PM for refrigerant-based applications at Siemens Smart Infrastructure. Alexander, thanks for joining us today.
Thank you, Joe.
Now, let's dive straight in, Alexander. And today we're talking about heat pumps. Before we get into the efficiency, the sustainability, and all the rest of the exciting topics today, let's talk at the very start about what a heat pump is. Can you give us a summary? What is a heat pump?
Well, a heat pump is a device that transfers thermal energy from one location, also known as the heat source, to another, called the heat sink. It operates on the principle of moving heat rather than generating it, making it energy-efficient heating and cooling system. One common example of the heat pump in our daily life is the air source heat pump, used for home heating and cooling. These heat pumps extract heat from the outdoor air during the heating season to warm the interior of the building. In the cooling season, the process is reversed, basically, and the heat pump removes heat from the indoor air and releases it outside. So in general, heat pump technology is widely used in many products like dryers, electrical vehicles. Heat pumps are very simple. They are functioning like a reversed refrigerator, extracting heat from air, brine, or water and elevating it.
Amazing. Thanks very much for the explanation. And you mentioned there really quickly that this does heating and cooling, but also that this is an efficient approach. Why is this technology so important, and how can it contribute towards sustainable and energy efficient buildings?
Electrical heat pumps boost energy through COP, also called coefficient of performance. Means converting 1 kilowatt, for instance, of electrical energy into 3 or even 5 kilowatts hours of thermal energy, depending on operating conditions. As we know, building sector is one of the biggest consumers of fossil fuels, mainly for comfort heating. Oil and gas burners are widely used. So for that reason, heat pumps are gaining more and more attention in the building sector, offering an economical, sustainable alternative for comfort heating without being considered as a niche or bridge technology.
So you mentioned there a good alternative. But we really see an extremely strong demand, a strong drive to convert and push towards heat pump technology. What's driving that in the market at the moment, Alexander?
On the one side, we see government incentives, especially in the European market. We see strong government support for heat pump technology. Many countries offer subsidies for heat pumps, coupled with carbon taxes, making fossil fuels more expensive. On the other side, there are environmental considerations. We have regulations in place favoring the adoption of heat pumps. Based on these facts, we can anticipate positive market growth for the next 10 to 20 years due to significant market potential. In summary, heat pump technology plays an important role in promoting sustainability in buildings by improving energy efficiency. And at the same time, heat pumps reduce carbon emissions, integrating renewable energy sources.
So pushing us towards more efficient buildings, so saving energy, also giving us a more effective way to use renewable and sustainably generated electricity to heat and cool. And all that can provide this heating requirements or this cooling requirements, as you mentioned, in this extremely high area of demand in buildings. Now, heat pumps are not new. The technology we've been talking about so far has been around for some time. And as you've already described, it's already efficient. But are there opportunities? What does the future of the heat pump industry look like? And is there more chances for us to make them even more efficient than they are today?
Well, on the component level, so if we take a heat pump apart and see on the components like compressors, fans, drives, but also heat exchangers, there were significant improvements done over the past decade. The remaining potential, I would say, for efficiency increase for individual components is very low, in the area of maybe single digits. However, if we look on heat pump controls, there is a significant potential for efficiency increase. Maybe let me give you an example. The common efficiency rating for heat pump is a seasonal coefficient of performance, also called SCOP. It's more or less realistic efficiency rating for heat pumps, considering different operating and load conditions throughout the year. So if we compare two identical heat pumps, one with standard control solution and another with custom software with advanced functionality, we will see difference in SCOP in a range of 20 to 30%. Another important level of efficiency optimization is the heating system controller. It plays a crucial role in overall efficiency, particularly in complex systems with multiple heat sources, circuits, storage tanks, and so on. So accordingly, a well-coordinated heating system controller can result in significant energy savings.
So we have a technology which is great today. It's efficient compared to many of the other heating and cooling technologies we have deployed in the past. It gives us the opportunity to leverage electricity as the key energy source here, or the key driving source. So that takes away some of the reliance on fossil fuels. It also enables us to really engage with renewable energies moving forward. What are some of the challenges? What are some of the things that we need to consider, knowing that heat pumps aren't perfect? What are some of the things that we need to be aware of, Alexander, as we start to see them and deploy them more and more into the world?
First of all, heat pumps need suitable installation area, such as roofs or gardens, for instance, for an air-to-water heat pumps, or also spaces inside for ground sources heat pumps with geothermal probes outside in the garden. Another important point is the temperature level of the heating system. Heat pumps are efficient for low temperature systems, but less so at high temperature differences. So basically, efficiency is influenced by the temperature difference between the heat source and radiator, which makes heat pumps ideal for underfloor heating or with fan coil units. Buildings with underfloor heating or low temperature radiator, let's say below 50 degrees C, can potentially be equipped with heat pumps. On the other side, traditional radiator systems operating at high temperatures around 75, 85 degrees C are less suitable for it.
I understand. So that's a really good, important point there, I think, and it's a great place for us to wrap up today. So the intention here, a heat pump, the technology, it's not a one-to-one replacement of some of the technologies you mentioned before, gas-driven or oil-driven boilers. They don't do exactly the same thing in the same way, but they can be a really good alternative when you have these situations. Alexander, thanks so much. I really appreciated the conversation, and I think we've got a lot more to learn about heat pumps. So I look forward to talking with you again. And looking at a little bit more detail into some of the technology around some of the additional activities which are happening around the controls in particular of heat pumps, and also into how those controls are then enabling us to drive digitalization and digitally connected technologies, etc. But until then, Alexander, thanks so much for sharing your time, for sharing your knowledge. It's much appreciated, and we look forward to talking to you again soon.
Yeah, you're welcome. Yeah.
Amazing. And a big thank you to everyone out there who's also listening to us. Remember to share, like, subscribe, comment on this episode, and always check out for every couple of weeks or so new episodes where we talk about exciting technologies like heat pumps or other things that are happening in the infrastructure and building world. So remember to jump onto the platform where you are today, listening to this podcast, and always keep your eye out for what comes next. We're going to be talking to Alexander more in the future, I get the feeling. So you can always get an opportunity there. So please keep your eye out for that. A big thank you again to Alexander and a big thank you to you. And we will talk to you very soon. Thank you.